Talk about this.
You're actually scared of that?
So pressure. If you ask Billy Joel or other people, what would they tell you that pressure is?
Pressure, it's...
I'm under such tremendous pressure.
You're under some force. Stress.
Stress. So you're all stressed out. Or they talk about blood pressure, right?
I know, that's stressed out right now.
My blood pressure is so high I have to reduce my salt. Ran into an Egyptian friend of mine just the other day, and he's like, oh, it's awful. I went to the doctor. He says, blood pressure is too high. I have to reduce my salt, but Egyptians love salt. I don't know what I'm going to do. I said, well, does that mean you can eat less salt? Yes, that's what I'm going to do. I said, did it reduce your blood pressure? Yes, it did. So he's not happy about it.
I'd say my dog's going to get a lot of blood pressure.
I know.
He eats like this much soy sauce.
So what is it about salt or sodium that actually increases blood pressure? Anybody know?
Is it the chemical composition that blocks?
It's one of the things that,
Makes it go faster.
yeah, so it's one of the
It's a stimulant.
ions that your heart uses to actually beat. Boom, 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 boom. So it's beating harder. So pressure. Pressure in physics is essentially a force over area. So remember, it's that push or pull, but it's over a given area. So in this case, we have newtons per meter squared, because area is just length times width, usually, right? So it's one thing for me to come along and hit Andrew in the head like this, yes, with my hand. It's another thing to take this thumbtack and do the same thing. Now he says, oh my gosh, why does he not want to be hit by the thumbtack? It's the same force.
Same force over less area.
Less area. So that's why that works. That's why knives work, because you take that force over a small area, you have tremendous pressure. And that's what it takes to split your bread, split your meat, split your french fries or asparagus, whatever you're eating. Or if you're the axe murderer, then you're splitting people, right? So with an axe. But that's what it is. It comes to a point, it's a very small area, same amount of force causes a lot of pressure. Question?
Is that how the nail beds work?
That's exactly how nail beds work. Because on a nail bed, you have a whole bunch of nails, right?
They're all
Right? And so you take your force, i.e. your weight, and you distribute it over your foot. So your foot is being covered by a whole bunch of different nails. And so since you have plenty of area, here, then the force is distributed and the pressure is not great enough for that nail to punch through. So it's no big deal. You can do the same thing with 2, 4, 6, 2, 4, 6, a dozen eggs. You can take a dozen eggs, put them in your curtain, walk on them, and they're not going to crack because you're distributing your area over all those eggs. Pretty cool, huh? Yes, sir. Ma'am.
Can you, are you ever going to show us that example of that in class?
That's a good idea. We should do that. Write that down. Let's get a couple dozen eggs. We'll have Miss Earnhardt demonstrate in class.
We should have Indy demonstrate the nail bed idea.
It's certainly, yeah, it works. Works great.
No, well, you can't stand on the nail bed, but you can lie down.
This is also why people wear these funny things. They used to look like this. Now they just kind of look like this. Snowshoes. Says here the Eskimo. You get up, you're in glue. You step outside, and you forgot to put on your snowshoes when you're going to get the paper. And what do? You fall right through the snow, 10 feet. You're looking up. You're like, help me. You have to wait for everyone else to wake up, right? So it'll be a while. So instead, you strap on your snowshoes, and you've increased the area of that force, your weight. So you increase the area, instead of being on your foot, a lot of pressure, you increase the area, reducing the pressure, and then you can walk on top of snow. Pretty cool. Same thing happens if you have those water walkers. You ever see those where they have the poles with the big water walker things? You can walk on water.
Not really.
Well, you can, right? Because you distribute your force over a greater area, and so the pressure is not big enough to cave a hole into the water.
But then what happens when you just go, and your legs start changing?
Like this?
It hurts, yeah.
Now you got to work on your groin muscles. Keep them together.
But it hurts so much.
It does hurt, yeah. If they split apart like that, it hurts, unless you're a girl and are a gymnast. So combine those two, you're fine. Okay. He brought it up. Anyone else use those water walkers?
I've used them once.
Good exercise actually is rollerblading. That really works on your groin muscles.
Okay. Can we talk about pressure?
Well, there's a lot of pressure in those groin muscles.
No!
Okay, next. Thank you. So, at the bottom of 391, it says that water pressure increases as depth increases. Why would water pressure increase as depth increases? So we have water, right? And then we have more water, and it's getting deeper and deeper. So the question is, why does pressure... So we have high pressure here, low pressure here. Why does pressure increase as you go deeper? Yes, sir?
Because you have all the weight of the water above you.
All the weight of the water above you. So right in here, you just have the weight, which is going to be, remember, weight is a force, and force is measured in newtons. So you have just the weight of this water right here. Well, what was pressure? Force over area. Well, then again, you have down here, you've got the weight of the water, 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 until finally, you have all this weight adding up, adding, until right here, you've got a lot of force, i.e. a lot of weight on top of that. So it's one thing for an elephant to pick up another elephant on their trunk and twirl them around, but if you throw a couple more hippos on top of that, the trunk might have problems, right? Because that's a lot of pressure on that trunk. No.
I did.
Not until now. So you go out in the water, and okay, so let's say you take a balloon. You got down there taking it?
Yes.
All right, so you take a balloon right here versus the balloon right here.
The balloon gets smaller.
So what's going to happen to the balloon there? It's going to what? Of course it's going to go up. Let's say we stick it down there with a rock or something. Stay down there. How's it going to look here versus here? It's going to, which one? Which one's going to pop? Oh, reverse it. The top one will pop, possibly. So let's do it this way. Let's say we take a balloon. Let me reword this. Let's say we take a balloon here, and then we stick it in the water. What's it going to do? It's going to...
It's going to contract those and be smaller. And the reason
It's not going to contract, but it's going to... It's going to get smaller. Why?
Because the pressure is going on the pressing on the balloon.
Sure.
And it would be more likely to pop towards the top than...
So you push it on the balloon, right? And gas is highly compressible. Down here, is it greater or less pressure than up there? Greater. So there's a bigger push, so we're going to have a rinky-dink balloon. Right? Very small balloon. Okay. Let's say we have a submarine down here. Okay, so we got a submarine down there, and we blow up the balloon, and then we release it right here. Okay, so it's just an ordinary balloon, and then we let it rise to the top. What's going to happen to the balloon as it rises to the top? Yes? Then it's going to pop, because as it gets higher and higher, it's less and less pressure, and so over here, it's going to be bigger, and here's going to be bigger, until finally it goes pow, because the balloon cannot contain all that gas. Yes?
Isn't that basically what causes the bends?
In a way. The problem is that the gas is trapped in your blood, and so it expands until it destroys cells and starts to hurt. Yes?
Would this work with a balloon that's not good?
Oh, yeah. Any balloon. Because, we'll get to that in 13.3, I think, when we talk about buoyancy. We'll talk about that later. Okay, so, yes, much greater pressure here because there's a lot more force in the same area. Okay. We're all right with that? Okay. Got to clear this ink and moving on. All right. Let's turn the page. Air pressure. Aha. So, here we have little city, houses, chimney, big tall mountain with trees and birds' nests and stuff. Okay. So, and we have to have some birds here. And clouds. Okay. Clouds. So,
Good clouds.
oh yeah, and let's get our ocean over here. Okay. Alright. And boat. Okay. So, that's a boat. You can't tell? That's what's half a boat.
Is
Looks
that
like
like a nuclear reactor in
tells
the
you.
middle?
So, let's review. Pressure, 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 pressure. Okay, let's rank these. We have 5 different pressure areas. Which one is the greatest pressure? Which one's number 1? White.
The one with the ladder.
This one down here?
Yeah.
So you say this is number 1? How many people agree with white? Okay, that's a good idea. Maxon, what's number 2?
The one right under the water.
Number 2. I agree with that one. What's number 3? Yes? Very good. Number 3. Number 4? Yes?
The one above number 3.
Okay, and then number 5 must be the last one. And that's exactly right. So we have high pressure here, low pressure here. So it goes all the way through the atmosphere. Why does it go through the atmosphere? What does the atmosphere have? What's in the atmosphere? Air. And what makes up the air? Different gases, and gases have mass. Right? And mass has weight, and so therefore, oh dear. So therefore, if this is an ocean, and we find that with greater mass, which is weight, when you add gravity to it, which equals force, so if you add force on force on force, you have huge pressure, right? Well, up here we have an ocean of air. So air on top of air on top of air, it's getting greater and greater pressure, right? So down here at sea level is your greatest air pressure. Up here in the mountains and out in the reaches of space is the lowest air pressure. Okay with that? So this does the same thing in air. So this is the least, this is the greatest, this is the least, this is the greatest. And this all happens to be coordinated by that wonderful thing called the gravity, right? Where is the center of mass of gravity of the Earth? It's near the core, right? So as you go down, it gets greater, greater, greater pressure. So let's take an airplane, right? So we have an airplane here versus an airplane here. Let's say it's an identical airplane, obviously, as you can tell from the drawing. So, identical airplanes. All right, which airplane is experiencing greater air pressure? Yes. The one right here, right? So which one has a greater ease of thrust? Yes. Try again.
Oh, the one in the middle.
Yeah, so it's really easy to push here and push back. Right? Action, reaction. It's pushing on the air pushes back on it. Up here, there's less air to push. So it's actually harder to move around. And eventually, it's harder to fly an airplane.
So that's why airplanes don't fly in space. It's just all standing.
That's why airplanes don't fly in space. You don't need wings in space. There's no air to push on. Right? Now, here's another thing. Let's say you're in the airplane, right? And you fly at 30,000 feet. There's something that they do inside of the airplane because you're that high. What do they do? They pressurize it. So, in fact, they pressurize it on the inside because it's really hard to breathe. There's not much air. There's not much air molecules beating around, not much force per area. And so it's hard to breathe. Because what happens when you breathe?
They take in oxygen.
You lower your diaphragm, which expands the lungs, creating a larger area. So you're decreasing the pressure here, right? Which means that air is going to push in. Not a problem. But if the air pressure on the outside is still less than on the inside, there's no push. It's really hard to breathe. And so, as Granlund said, they pressurize the airplane. They don't fully pressurize it. What would happen to the airplane if they fully pressurized it to atmospheric pressure? What would it do?
It would explode.
It would boom, expand out, and explode. It would hurt the airplane. So they only partially pressurize it. So it's still easy enough to breathe, but not so much to destroy the airplane. Because, here's a rule. Write this down. This is a good one. So pressure always goes from high to low. As it is, since they partially pressurize the airplane, it is expanding out a little bit as it goes up. If they fully pressurize it, then it would go from high on the inside to low on the outside and explode, as Mr. Moore said. Right? Boom. Now, so what happens to the submarine?
15 minutes.
So you stick... Oh, thank you. Well, that's good. Let's see if we can stop that.
Stop it.
Didn't end it.
Oh, stop. Oh, no, please.